In our previous video, we continued with our dummy coding example based on different academic programs, focusing on the coefficients table and how to interpret the intercept or the constant, as well as the math-intensive curriculum coefficient. Let's now wrap up that analysis by looking at the coefficients for the remaining two dummy variables. Okay, now here's the regression equation, right? Let's plug in values for the dummy variables to get our predicted score for the language-focused curriculum. Now, the predicted score for students in the language curriculum would be equal to the intercept plus, let's see, if you're in the language curriculum, would you be in the math curriculum? No, so I'll plug in a 0 for the math dummy variable. Would you be in the language curriculum? Right, we're in the language curriculum, so I'll plug in a 1 for the language dummy variable. And would you be in the intensive curriculum? No, so another 0 down there. That makes the regression equation 460.101 plus 80.792 times 0 plus 71.472 times 1 plus 45.241 times 0. Right? Now again, those zeros are going to drop out, so that reduces to 460.101 plus 71.472, which solves to 531.573. Our predicted score for someone in the language-focused curriculum is 531.573, which, you guessed it, well, if you watched the previous video, is the mean for the language-focused curriculum within rounding again. All right. Now again, that works here because we're not adjusting for any other variables, all right? Now, similar to what we saw with the math coefficient, the language coefficient is equal to the difference between the language-focused curriculum and the standard curriculum. You see it again right here, right? We're taking the intercept, that mean for the reference group, or the mean for the standard curriculum, and we're adding 71.472 to it. The 71.472 is the effect for the language-focused curriculum, right? And we see it in the regression coefficient. It's how much higher or lower the language-focused curriculum is relative to the reference group, which is the standard curriculum, right? And the t-test for the language-focused curriculum tells us whether that difference is so large that we're convinced it's not really just 0 out in the population, right? So what do we see? Our t-test tells us that the mean for the language-focused curriculum is significantly different from the mean for the standard curriculum, with a t with 396 degrees of freedom equal to 3.008 and a p-value of 0.003. Out in the entire population, these two groups seem to have different means. They're not the same. All right? And while our specific point estimate of the size of that difference is 71.472, we're 95% confident that the true difference between the language-focused curriculum and the standard curriculum across the entire population of students getting these curriculum, we're convinced that the true difference is somewhere between 24.766 and 118.177. We're 95% confident it's somewhere in that range, right? Now, why don't you pause the video and see if you can calculate the predicted score for someone in the intensive curriculum and interpret what the coefficient for the intensive curriculum is estimating. Restart the video when you're ready, all right? Okay? Did you see the pattern here? Let's check it out. Well, if someone is in the intensive curriculum, then they're not in the math curriculum and they're not in the language curriculum, so both of those dummy codes would be 0. But they are in the intensive curriculum, so that dummy code would be equal to 1. The equation then reduces down to 460.101 plus 45.241. Right? That gives us our predicted score for students in the intensive curriculum, being equal to that, which is just 505.342, right? Now, which I'll note is equal to the mean for the intensive curriculum, right? Now, with dummy coding, the intensive curriculum coefficient is equal to the difference between the intensive focused curriculum and the standard curriculum, our referent group, right? And again, just like we've seen before, we're taking the mean for the referent group and we're adding 45.241 to it, right? Which is the value of the intensive curriculum coefficient. With dummy coding, that coefficient, 45.241, is how much higher or lower the intensive curriculum mean is relative to the referent group, right? Relative to that referent group, which in this analysis, the referent group is our standard curriculum. Okay. Now, let's do another little check here. And why don't you look at the t-test and the 95% confidence interval for the intensive curriculum effect and see if you can interpret both of them, okay? Restart the video when you're ready, all right? Okay? It's a little different this time, isn't it? Notice that based on our t-test, the difference between the intensive curriculum and the standard curriculum is not statistically significant. Our t with 396 degrees of freedom is equal to 1.904, and our p-value is 0.058. So we're not sufficiently convinced that the means for these two groups are different in the population. Right? Oh, I mean, they're different in our sample, of course, but that difference isn't large enough to convince us that it's not just random noise. The difference we see in our sample just isn't large enough to convince us that we should reject the null and conclude the two means are really different across the entire population. And did you notice how that's reflected in the 95% confidence interval? We're 95% confident that the true difference between the intensive curriculum and the standard curriculum across the entire population of students receiving these curriculum. We're 95% confident that true difference is somewhere between negative 1.464 and positive 91.946. This is the range in which we think we would find the true difference between these groups out in the population. And sure enough, notice 0 is in that range. In essence, the confidence interval tells us the range of plausible, believable values for how big the difference really is between the two groups. And 0's in that range. 0, no difference at all, is therefore a plausible, believable value. In that case, how can I reject the null? The confidence interval tells me the null value of 0 is entirely believable. All right? Now, you may not have articulated it like that, but if that's what you were thinking, that is excellent. And if what I just said makes sense, even if you weren't thinking of it on your own, then that's very good too, all right? Now, before we wrap up dummy coding, there are a few final points I want to make. First, remember all of the dummy variables need to be entered as a set. If you're conducting a sequential multiple regression and adding academic program at some step in that analysis, you got to enter all of the dummy variables together in that step. Now, as an aside, this shows another problem with stepwise regression. Stepwise regression will just automatically add or remove individual dummy variables, not the entire set. Now, there are workarounds for that, but just don't do it, okay? Second, I want to emphasize again that we're able to perfectly estimate group means because we didn't include any other correlated predictors. As we saw within statistical control, right? The effect for one variable will change if we add other correlated predictors. In that case, we would be estimating adjusted means, group means that have been adjusted for those other variables. We'll actually address that in a later video. All right? Third, choose your referent group logically. Remember, the regression coefficients will compare each of the other groups to that referent group. Notice that in this example, our referent group was students in the standard curriculum, and we compared 3 alternative curricula to the standard curriculum. I set it up that way to make a clean, clear, obvious choice for the referent group. Now, ideally, the referent group is something like a control group or a comparison group or maybe a business as usual condition. And as we saw here, you may have several alternative programs or interventions that you want to compare to a business as usual or a standard curriculum group. Using the business as usual or standard program as the referent group makes sense in those situations. Or maybe you want to compare individuals with different types of health problems to a group with no health problems. Having a no health problem referent group also makes a lot of sense. So think carefully and don't just pick a referent group willy-nilly, all right? Finally, as this suggests, dummy coding is good for situations where you have one group to which you want to compare all of the other groups, all right? But what if there is no one group that you want to compare others to? What if there is no natural comparison or referent group? What do you do then? Well, we'll look at a different coding scheme for that situation in another video. But for now, take care. Bye-bye.